Hello. For those of you who don't know me, I am Mrs. Wall and I teach statistics here at Kearney High. Today, we are going to be talking about simple probability. When working with probability, we typically are discussing experiments and their outcomes and the likelihood of a specific outcome. So we're first going to take a moment to define what is an experiment. And an experiment is an investigation or procedure with varying results. So sometimes these are called events, different things that we could do that would have different outcomes. For instance, rolling a number cube or taking a card out of a standard deck of cards or flipping a coin. An outcome is a possible result from our experiment. So our example of an experiment, flipping a coin, has two possible outcomes. One of them is heads and the other is tails. And a sample space is when we list the set of all possible outcomes. Now, when we do this, we list it in what is called set notation, which means we're going to list each one within brackets separated by commas. So there are two outcomes for the event or the experiment flipping a coin. It could land heads up or it could land tails up. And a sample space allows us to see all those possible outcomes so that we can then calculate the probability of certain events. So what is the sample space if our experiment is picking a state that begins with the letter O? So our states that begin with letter O would include Ohio, Oklahoma, and Oregon. This would be our sample space because these are all of the options that we have to choose from, and there are three possible outcomes. What if we say, pick a day of the week? Well, when we pick a day of the week, we are going to choose from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. That's our sample space. That is a list of all of the possible outcomes, and there are a total of 7 outcomes. Once we know our sample space, we can measure the probability of an event. And probability is a measure of the chance of a specific event out of our experiment or a specific outcome from our experiment occurring. And we write probabilities P of E. E, in this case, would be the specific event that we are discussing. When we talk about probabilities, we can express them in any number of ways, including a ratio of the favorable outcomes, which are the ones that we are finding the probability of, over the total possible outcomes. And we can write our ratio as a fraction, a decimal, or as a percent. The sum of all of the probabilities in a sample space must add up to 1. One of those outcomes must occur if the event takes place or the experiment takes place. So here we have a spinner, and our spinner has been divided into 16 sections. 1 and 2, 12 through 14 are not shaded, and 3 through 11 are shaded. We're going to calculate some simple probabilities here, which means they're the probability of just one specific outcome. So the probability of a 9 would be the likelihood of getting a 9 out of all the possible outcomes. So there is one favorable outcome out of 16 total outcomes. That probability as a fraction is 1/16. We could also write it as a decimal, 0.0625, or we could write it as a percent, 6.25%. What's the probability that we get a result that is at least 12? At least 12 means it could be 12 or bigger. So that would include all of these outcomes. There are 1, 2, 3, 4, 5 outcomes that are at least 12 out of 16 total outcomes. 5/16 would be our probability. As a decimal, that would be 0.3125. And as a percent, that would be 31.25%. What's the probability that we are going to spin a number that is a perfect square? Our perfect squares are the answers we get when we multiply a number by itself, a counting number by itself. 1 times 1 would give us a perfect square of 1. 2 times 2 gives us the perfect square 4. 3 times 3 gives us the perfect square 9. And 4 times 4 gives us the perfect square 16. Anything bigger than that is not going to be on our spinner. So it looks like out of the 16 possible outcomes, 4 of them are perfect squares. Our fraction 4/16 can be reduced. So we would write that as 1/4, as a decimal, 0.25, as a percent, 25%. What's the probability that we are going to spin and land on a non-shaded section? We have 1, 2, 3, 4, 5, 6, 7 sections of our spinner that are not shaded. So the probability we land on a non-shaded section is 7/16. As a decimal, that is 0.4375. And as a percent, it is 43.75%. What's the probability we roll or spin a 2 or an 11? 2 or 11 means it could be one or the other or both. In this case, it can't be both. It's either 2 or 11. So that includes 2 of the 16 possible outcomes, or a probability of 1/8. That would be 0.125 as a decimal and 12.5% as a fraction or as a percent. What's the probability we get a multiple of 5? So multiple of 5 means it's a number we get when we take 5 times the counting numbers. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. That gives us 3 possible outcomes out of 16. And that gives us a probability of 3/16, 0.1875, or 18.75%. Let's take a look at another example of an experiment. So for this one, our experiment was spinning the spinner. What if our experiment is choosing a month of the year at random? What is the probability that that month will start with the letter J? How many months start with a J? January, June, and July. So 3 out of how many total months? 12. That's a probability of 1/4, 0.25, or 25%. What's the probability it starts with a T? January, February, March, April, May, June, July, August, September, October, November, December. None of the months start with T. So that would have 0 out of the 12 outcomes, which means the probability that's going to happen is 0. As a decimal, it's also 0, and it's 0%. A probability of 0 means that something is impossible. There's no way that it can happen. What is the probability that the month has at most 30 days? At most 30 means it can't have more than 30. So January, February, March, April. Do you know how many days are in each of those months? If you've ever heard the rhyme, 30 days has September, April, June, and November. All the rest have 31, except for February, which has 28, and on leap year we add 1. So the months that have at most 30 days are September, April, June, November, and February. That is 5 of the 12 months. That can't be reduced, but as a decimal, it is 0.4167 or 41.67%. The next one is a little bit different. We're going to look at the word probability, and we're going to choose a letter from that word at random. What is the probability that the letter we choose is a B? How many of the letters in probability are B's? 2 of them. How many total letters are there in the word probability? There are 11. 2/11 is the probability we will pick a letter B, and that would be 0.1818. It's repeating, but this would be our truncated decimal, and 18.18% probability. What's the probability we pick a vowel? Vowels are A, E, I, O, U. So that would be O, A, I, and I. There are 4 vowels in this word out of the 11 letters, which is a probability of 0.3636 or 36.36%. What's the probability we pick the letter Y? There's only one Y in the word probability, so the probability would be 1/11. As a decimal, that's 0.0909, and as a percent, that's 9.09%. 2 more examples of simple probabilities here. A pencil box contains 5 red, 6 yellow, 8 blue, 3 orange, and 2 purple colored pencils. If one is chosen at random, find each probability. Now, there are 1, 2, 3, 4, 5 colors, but there are actually 24 possible outcomes. Does anybody know why there are 24 possible outcomes? Because we have multiples of each color. So what we want to do to find the number of possible outcomes is add together how many there are of each. 5 plus 6 plus 8 plus 3 plus 2 gives us 24 possible outcomes. So the probability we pick a yellow pencil would be the number of yellow, 6 out of 24. That's a probability of 1/4, which is 0.25 or 25%. What's the probability that we pick blue or purple? Well, there are 8 blue and there are 2 purple. So that gives us a possible of 8 ways. Nope, 8 plus 2 is 10, sorry. That gives us 10 ways that we could pick a blue or a purple out of the 24 total outcomes, which is 5/12 or 0.417 or 41.7%. What's the probability that we pick a pencil that is not orange? Not orange would mean it has to be red, yellow, blue, or purple. That's everything except the 3 orange colored pencils, which add up to a total of 21 pencils out of 24. 21 out of 24 is 7/8, which is 0.875 as a decimal and 87.5% as a percent. The next example requires that you know a little bit about a standard deck of cards, because we're going to pick a card from a standard deck and find the probability of either a queen, a red 3, or a spade. So decks of cards have 52 total cards, and there are 4 suits. There are hearts, diamonds, clubs, and spades, and there are 13 of each kind of suit. Within each suit, there is ace, 2, 3, 4, 5, all the way up to 10, a jack, a queen, and a king. So the probability of a queen is 4 out of 52 because there are 4 queens in the deck. There is a queen of hearts, a queen of diamonds, a queen of spades, and a queen of clubs. This reduces to 1/13, which is a decimal of 0.70769 and a probability of 7.69%. The probability we pick a red 3 There are 2 3s in the deck of cards that are red. There is a 3 of hearts and a 3 of diamonds. That reduces to 1/26, which is a decimal of 0.0385 or 3.85%. The probability that we draw a spade from a deck of cards would mean that it could be any spade from ace all the way up to king. And there are 13 cards in each suit, so there are 13 spades. 13 out of 52 is 1/4, which makes sense because a fourth of the deck are spades. That is a decimal of 0.25 or 25%. The last thing that we're going to talk about today is the complement of an event. And the complement of an event is the probability that the event does not happen. Since all of the probabilities in a sample space add up to 1, the probability of an event not occurring is 1 minus the probability of the event occurring. This is noted with a little wavy line in front of the E, which means not. There are some other notations that you might see, but this is the one that we're going to use. And as I said, the probability of all the events add up to 1. So if you know the probability that the event will occur, you can subtract that probability from 1 to find the probability that it will not occur. Here are some examples of complements. If the probability that it will rain tomorrow is 3/8, what's the probability that it will not rain? So the probability of rain is 3/8. Then the probability that it will not rain is 1 minus 3/8 or 5/8. If the probability that someone will win a game at a carnival is 1/24, what's the probability that they will not win? Or what's the probability that they will lose? Probability they will not win is 1 minus 1/24 or 23/24. A number from 1 to 20 is chosen at random. What's the probability that it is not prime? This time they haven't told us the probability of a prime. We have to come up with that ourselves. Prime numbers are numbers that can only be divisible by 1 and itself. The smallest prime number is 2. From there, the next prime number is 3, then 5, 7, 11, 13, 17, and 19. That gives us 1, 2, 3, 4, 5, 6, 7, 8 prime numbers between 1 and 20. So the probability it is prime is 8 out of 20, or 4/10. That can be reduced even further to 2/5. If the probability of a prime is 2/5, the probability that a number is not prime would be 1 minus 2/5, which is 3/5. Our last example, if a state is chosen at random, what is the probability that it does not begin with the letter M? This one's a challenge. I'm not a geography teacher. How many letters begin, or how many states begin with the letter M? Let's see if we can name them all. We have Maine, Mississippi, Missouri, Montana, Maryland, Massachusetts, Michigan, Minnesota. There are 8 states that begin with the letter M. So the probability of an M state is 8 out of 50. 8 out of 50, which reduces to 4 out of 25. So the probability that it is not an M state would be 1 minus 4 out of 25, which is 21 out of 25. That's how you can calculate the complement of an event by subtracting from 1. This is simple probability.